Today we're going to talk about pump efficiency, such an important term. We're going to define what pump efficiency is, why it is so important, and the last one, but not least, and I want you to stay until the end of the video to check this because it's going to be surprising. I'm going to tell you how pump operators are using pump efficiency today to improve their operations. So let's start. And for that, I'm going to change to this one here. Yeah. So what is pump efficiency? So imagine that you have, like here in the screen, you have a motor and then you have a pump. So to move the amount of water you need, then you need to put some energy from the motor to the pump. You need to rotate the pump. So let's imagine that you input here, and let's measure it from here. I put here, what is it here? You input here 100 units of energy. Let's call it UE. Kilowatts per hour, something, whatever you want. However, the pump uses, and this is kind of the shocking part, uses about 80 units of energy to do that job. Meaning that there are 20 units of energy that are not used to do the job that you hired the pump to do. Yeah. So whereas 100 to put 100 here, but there are 80 that are used to move the water. Where are those 20 going? Well, there are certain internal operations, like for example in the bearings, you have certain friction here that they're going to consume a little bit of that energy. But also you have here the impeller of the pump that is in charge of moving the water. Yeah. So let me just follow the shaft of the pump. Let me use this color. This is the shaft of the pump here. This yellow one here. Oh, I love this software here. Awesome. So the other part of energy wasted is, well, the impeller is pushing the water to one direction, but the water says, you know what, I don't want to go there, I want to go in other directions. Yeah. So not the whole movement of the impeller is going to be dedicated to push the water, but there are some other things. And finally, for more than we want, the impeller is not efficient, which means that it is not that good at doing its job. When we have this case like this, we say, well, you know what, the efficiency of this pump, I'm going to call it like this, ETA pump, is going to be 80 divided by this 100. And then, of course, you multiply it by 100 to turn it into a percentage, which means that this pump, in our case, is going to be 80%, or have 80% of efficiency. And we're talking just, from this part of the motor here to the pump. Why it is so important, then, we have defined what efficiency is. It basically is the relation that exists between the power used to move the water and the power that you fully put in the whole system to make that happen. Well, then what is important, because you are paying some money here. Yeah, we can do kind of dollars or euros, something like that. You are paying money to push water or to convey water to certain places. And part of that money that you're putting there is not fully used to do the job. So which means that the lower the efficiency of your pump, the more money in excess you have to pay to do the job. So meaning efficiency is highly tied to finances. Yeah, let's write it down here. So efficiency is, is fully related to money. Now we understand that, the better the efficiency, the better for it is. And it's such the case that whenever you want to design a full system, imagine that you have a tank here at a reservoir, water reservoir here, and then you want to move this, you want to move this much to here, you want to move water. So you put a pump here, and you're just going to draw the pump something like this, like simple. This is a pump here. You hire somebody, because most probably you are not going to do it yourself, but you're going to have a design company do it for you. And then they're going to start selecting what is the material of the pipe, dimension of the piping, arrangement, layouts, everything. But they're also going to tell you, okay, what is the pump I need to use? And it is the case that several types of pumps and models can do the job for this case, for your specific application, to move water from point A to point B here. So one of the criteria they're going to use to select the pump is to use the most efficient pump. So efficiency plays a huge role in selecting the pump that you're going to use. So they're going to tell you, hey, here it is. This is the pump you need to buy. In case you're going to do it with some other company, that some other company is going to be in charge of buying things and installing everything. So they're going to tell you which is the pump, which is the most efficiency. And not only is tied to finances, but also is a decision-making factor on selecting the pump, because in the end, everybody tries to save money by using the most efficient, so you don't spend that much money in energy. It is such the case that it is known that pumps are one of the highest energy consumers in the world. When you have an industry that handles pumps or have pumps, they said that it could be that up to 40% or 50% of the energy consumed by the pumps is the energy consumed by the whole company, basically like that. So 50% of the electricity consumed by the company is by the pumps. Having this case, then in the past, a few years back, at least the European Union, what they said, as pumps are the largest energy consumers, in industry applications, and there are millions of them. So it would be a good idea to minimize that consumption. So, in the future, the rate of electricity consumption is not as high as we think it's going to be. So they come up with this resolution that practically forced manufacturers to say, hey, you know what? I want your newest designs to comply by this resolution, which means that you have to produce or design more efficient pumps. Because if you produce or you design more efficient pumps, what's going to happen is that they're going to consume less energy, and then consuming less energy, we're going to kind of slow down the consumption rate. So they did that. Beautiful. Also, in the United States, they did this kind of, took this kind of approaches where they said, we want manufacturers to increase the efficiency of their pumps so we can reduce the energy consumed by pumps. Beautiful. But this is how important it is. And basically, everything kind of is tied to the fact that the higher the energy, the higher the efficiency of the pump, the less energy it consumes. Now it comes to the surprising part that I told you to wait till the end. So how do pump operators use this information in their day-to-day operations? Well, my friends, let me tell you here, and let me change to this part here, that I love this software, that they don't. Basically, manufacturers are forced to produce more efficient pumps. The European Union, United States, the Department of Energy said, you have to produce most efficient pumps. The guy or the people who designed or selected the pump for your system said, this is the most efficient pump. And then when operators, are taking the whole system into control, they don't do anything with that information. Basically, they don't follow the evolution of the efficiency. Because let's be clear, pumps are mechanical equipment, and they're going to deteriorate. And as they deteriorate, efficiency is going to go down, which means that you're going to spend more money to do the same job. They do nothing. And for me, it was shocking to understand this kind of reality. You go to a factory, you go to an industry that they have pumps, and then just, hey, did you measure the efficiency of the pumps? And they would say, no, they're working fine. So why they do this, why they don't follow such an important indicator, well, that's a topic for another video that I'm going to prepare for you. But this is happening. I'm not saying that all of them are in this team that, that they just don't care about the pump efficiency as long as it's pushing water. But the vast majority did not follow pump efficiency. But now that you know this information, I want you to tell me in which team you are. Are you now in the team that is going to follow pump efficiency? Or are you in the team that says, you know what, I don't care about pump efficiency, even though there is a lot of things going on with that simple indicator? Leave me a comment down below if you have an idea or have something that you want to share. And if you want to talk about life cycle costs for pumping systems, reach out to me. My contact information is also published there. Bye.